Hello. Today we're going to do lesson 14. We're going to be making graphs or putting plots on the coordinate plane, and we're going to get the information from ratio tables, equations, and double number line diagrams. Let's get started. So Kelly is traveling by train with her soccer team from Yonkers, New York to Morgantown, West Virginia for a tournament. The distance between Yonkers and Morgantown is 400 miles. The trip will take 8 hours. The train schedule is provided below. And I'm not going to read all these out. You guys can do that. So here's our data right in here. And let's see what we can do with it. Create a table to show the time it will take Kelly and her team to travel from Yonkers to each town listed in the schedule, assuming that the ratio of the amount of time traveled to the distance traveled is the same for each city. Then extend the table to include the cumulative time it will take to reach each destination on the ride home. So let's take what we know right now. We know that leaving Yonkers, the first stop is going to be 100 miles. And our second will be 200, and so on. So I'm going to 300, and then 400 gets us to West Virginia. Then the second part of the question says extend it, so I'm going to do 500, 600, 700, and 800. Oh, 800. And also from our question, we know that the distance between Yonkers is 400 miles. Use a different color here. 400 miles, and it will take about 8 hours. So going down to my table, 400 is 8 hours. Now, how do we fill in the rest? Well, I'm going to go down to my units down here. Between here and here, dividing by 4. So I'm going to do the same over here. That's going to give me 2 hours. So my ratio now is 2 to 100. I can fill all these in. 4, 6, 8, 10, 12, 14, 16. There's our table. Moving on. Now it says create a double number line diagram to show the time it will take Kelly and her team to travel from Yonkers to Morgantown. Sorry, that's covered. Listed on the schedule. Then extend the double number line to include the cumulative time it will take to reach its destination on the ride home. So I'm going to put 0 and 0. And this is going to have to be hours. I think this one will be miles, right? To match our table from before. Make this a little bit smaller for us. So according to our table above, it was 2 hours, 4 hours, 6 hours, 8, 10, 12, 14, and 16 hours. And the miles, it was what, 100, 200, 300, 400, 500, 600, 700, and 800. There's our double number line. Now, using the information from the double number line diagram, how many miles will be traveled in 1 hour? Well, if you notice, we don't have 1 hour on our map. We have 0, we have 2. But we know that 1 is going to be halfway between 0 and 2. So what is halfway between 0 and 100? It's 50 miles. So how many miles will be traveled in 1 hour? I'm just going to write the number, 50 miles. And how did we know? We know that because 1 is halfway between 0 and 2, that whatever the distance here is halfway between 0 and 100. And the answer is 50, because 50 is halfway between 0 and 100. Moving on. Oh, this is where it starts to get fun. Dinner service starts once the train is 250 miles away from Yonkers. What is the minimum time the players will have to wait before they can have their meal? So we know from before that 2 hours is 100 miles, 4 is 200, 6 was 300, 8 is 400, Let's just go 10, 500. So, here's my two columns. This is the exact same as 2 times before. 2, 100, 4, 200. So these are all the same. So now, ordered pairs is what we do when we're putting plots on a chart. If you remember from social studies, you needed longitude and latitude to find two spots. So you need ordered pairs. You need two things before you can do it. So let's make this our x, and this will be our y. We know that this line down here is our x, and this is our y. Hopefully you remember that from last year. So I need to label these. If this is going to be 0, I'll make this as a 2, 4, 6, it's slightly off, 8, and 10. Oh, and this, I have to label this. Ooh, hours. Now label, someone who just walked into class wouldn't know. So now I have to label the other side. I'm going to label this one miles. And I'm going to go 100, 200, 300, 400, 500. So there's my chart. That's labeled. Oh, one last thing. We need to have a title for the whole chart. And I'm going to label this one time and distance traveled. So let's just put our ordered pairs. If this is my x, and this is my y, then my ordered pairs are going to be 2 and 100. This is going to be 4 and 200, 6 and 300. Don't forget to put them in parentheses with a comma in the middle, because it tells me that there's 2 and that the x is first and the y is second. 8 and 400, and last one is 10 and 500. Now let's plot these. So the first one is, we're going to go over 2 and then up to 100. So I'm going to go over, here's 1, 2, and then I'm going to go up to 100, which is right here. I'm not going to go over 2 and up 2. I'm not going to draw that line. That's not exactly what we just want. The exact over 2 and up to 100, which is that point only. We only want the point. Now we're going to go over to 4, which is here, and then we're going to go up to the 200, which is there. I shouldn't have done that. I'm trying to model good behavior. The next one is going to be 6 and 300. You guys see the pattern so far? So I can plot the rest here, but I already know they're going to be in line. And if I had doing this on paper, I would use a straight edge. Doing the best I can. There's my graph. Now, let's see if we can answer the question. Dinner service starts once a train is 250 miles away from Yonkers. So, here's miles, 100, 200, 300. We know that 250 is right in the middle of 200, 300. So if I go across here, I'm going to go, and if I drew this line better, it would have been at that point right there, which is down to here, 5 hours. So, what's the minimum time? The minimum time is they will have to wait for a minimum of 5 hours. There you go. That's the lesson for today.